start today, I want to paint a picture of a typical construction site in Sweden. It's November 2019, and a large mega data center project is getting underway. The design team have completed the building designs. The foundations have been engineered, structural partitions mapped out, plumbing and electrics fully considered. The design is complete, pulled together in a fully developed 3D CAD model known as a Building Information Model, or BIM. The design is then passed onto the surveyors and the builders to set out and begin construction. However, a transformation has occurred in the process. Every layer of the 3D model has been converted into thousands of 2D drawings, which must be interpreted back into the real world out on site. We've gone from a totally natural dimension of 3D into a totally unnatural dimension of 2D. And somehow it's expected that our data center is to be accurately constructed using these 2D drawings. And so, a few months pass. The concrete foundations have been poured, and the steel frame columns arrive on site. However, there's a problem. The crossbeams are not lining up with the concrete foundations. There is a misalignment of 1.5 meters. All works must stop until the root cause of the problem is identified. A total of 3 weeks will pass. Various instruments and measuring equipment is brought in to try and find the root cause of the problem, comparing the dimensions on the 2D drawings to the real-world components that have been built out on site. It is found that the initial concrete foundations were poured in the wrong place. Rework is required, bringing further delays and cost. Which brings me on to my first question, which subsequently was the same question put to me by my CEO, David Mitchell, when we first met around 3 years ago. He said, "Guy, why is it that still to this day, the construction industry is unable to build buildings right first time? Why couldn't the mistakes on our Sweden site have been spotted sooner? And how did the builders get it so wrong? What is stopping the build being checked in real time before mistakes are actually made?" So let us rewind back to the start of our project. The surveyors are out evaluating the foundation markers on site ahead of concrete installation, due to arrive in a few weeks' time. They use their laser measuring equipment to cross-reference against the 2D drawings. It takes weeks to capture and analyze this data back in the site office, meaning real-time validation is simply not possible. It is a highly skilled job and one that often brings mistakes. They are stuck between this unnatural language of the 2D drawing and the 3D world that the site is being built in. Now, we've possibly all been there ourselves. You're out in IKEA ready to buy a new sofa, and you've scribbled down the dimensions of your room in 2D. And now, in store, you measure the sofa and then try and figure out where it will fit. You're trying to picture it in position back home, sketching away on the 2D drawing to see if it will look right at that angle. It's unnatural. You're stuck between two dimensions. You see, we all live in a 3D world. Every physical object in the real world exists in 3 dimensions: an x-axis, a y-axis, or a z-axis. 3D is a natural language that we as humans can understand. It provides context from one object to another object in space. Yet, still to this day, it really is fascinating how so much of what we design, engineer, and build is constrained by the unnatural language of 2D drawings. And in construction, this is a constant challenge that the industry faces, leading inevitably to things being built in the wrong place, bringing rework, overruns, and added cost. So why has technology today not yet provided the answer for construction? When you take a close look at the technology available, you begin to see a pattern. You see, so much of what is out there still centers around those 2D drawings. There's advancements in laser measuring technology, which allows surveyors to pinpoint mistakes with much higher precision. Yet they're still stuck interpreting that data against 2D drawings. When speaking to surveyors, it amuses me often to hear that their most useful tool out on site is actually an iPad. And not for its smart 3D scanning technologies or the use of Siri to ask them for the weather update tomorrow, but because now they have a digital copy of their 2D drawings to take out on site instead of the paper copies that they would often lose. See, technology is not solving the fundamental heart of the problem, but more just prolonging the problem by locking in the continuous use of those damn 2D drawings. Now, of course, we can look further afield. Some of you might have seen those cool new TV programs for interior design that use virtual reality headsets to showcase your new kitchen design whilst you stand back in their studio. These technologies are fantastic visualization tools. No longer are you stuck in IKEA trying to figure out how that sofa's going to look next to your grandma's antique Welsh dresser. And then you have augmented reality. Now, I remember a few years back, during my time as a product designer at Samsung, I visited a tech trade show in London and had been given an exciting new demo of the Magic Leap AR headset. In this instance, the tool was marketing itself as the future of construction. They had set up AR holograms of the new Tottenham Hotspur's football stadium as a scaled-down model that you could view and walk around on their display table. Again, a super cool visualization tool, but was a scaled-down model really the future of construction? So I asked one of the sales reps, I said, is it possible to view this at a one-to-one scale? It'd be so cool if you could actually see this model out on site as it's being built. His response, God no, not a chance. You try and imagine the file size of this 3D model of this football stadium. There's no way you could have that to scale on an AR headset, nor could it be positioned accurately enough for use out on site. Now, I hear people say the construction industry is so set in its ways, it will never adopt exciting new technologies. But you could argue the industry has simply been failed by technology to date. You have an industry stung by the empty promises of a Magic Leap headset, claiming the future of construction, which instead is simply leading to a lack of confidence and a fear of adoption. There is nothing genuinely targeting the root cause of the issue. A tool that eliminates the 2D drawing and replaces it with an accurate 3D hologram placed on site to one-to-one scale, allowing real-time validation and building. But clearly, a technological push on its own won't cut it. We must break down these barriers and overcome the fear of adoption. Only then can you start to achieve the holy grail of construction. Build it right, first time. And this is where I can introduce the XYZ reality story. So I want to paint you a new picture in the world of construction now. A new technology is emerging. A new tool aimed specifically to eradicate the need for the 2D drawings and finally enable buildings to be built right first time. We call this Engineering-Grade Augmented Reality. So let us go back to our site in Sweden. And as before, the design team have completed the building designs. Sign-off has been given. The 3D BIM model is complete. A transformation now begins, yet not one of converting the 3D model into 2D drawings. No, a new transformation. Through the use of our .xyz software, the 1 gigabyte full data center 3D BIM model is converted down into a clean 3D hologram, ready to be viewed on the Atom, a precision augmented reality construction headset, able to view 3D models to millimeter accuracy on site. Our surveyors now have a tool that can be used throughout the build phase, allowing them to conduct real-time validation. So let's head back to Sweden. The builders have laid foundations for a 500-meter pipeline running through the length of the construction site. Our surveyors load up the 3D BIM model in AR and begin to walk down the length of the trenches, accurately reviewing the 3D geometry to millimeter accuracy overlaid on top of the placed pipes. As the surveyors walk down the pipe trench, they start to see a deviation from the real world to the 3D overlaid hologram. It is found that from one end to another, the pipe deviates by up to half a meter. When they get to the far end, they can clearly see that the network of pipes that would connect to this central line would be completely misaligned. The mistake was spotted before the foundations were poured and before the installation of the pipes, saving hundreds of thousands of pounds in rework. Now, as I've already alluded to, we believe this technology cannot just be thrown at the industry. The fear of adoption is real, and so careful consideration for how our precision AR tool is rolled out is essential. Let's consider our builders still working away with their 2D drawings. They see surveyors walking around with these construction AR hard hats on, a soft yellow glow coming from their visor as they view the works through the eyes of engineering-grade augmented reality. The builder's work is now being evaluated in real time, critiqued by a precision tool that compares what is being built live against the original 3D designs. It's therefore only a natural progression that the builder will start to think, well, hang on a minute. If the surveyor is out there evaluating my work with this accurate 3D tool, why am I not just building with it from the first place? And so, through this natural adoption process, we see our Sweden site transition to becoming fully powered by AR. And we can take this one step further still. Let's take a look at our project managers, tasked with the complex job of keeping the project running on time, managing schedules and logistics of different contractors, arriving with materials and off-site build elements that all must piece together at the right time. Now, running all this in the office is one thing, but imagine being able to look directly at the 3D model, overlaid accurately on site, at different stages of the build, alongside date stamps fed from their schedule. In construction, this is known as 4D modeling, linking a 3D BIM model to a schedule. We now have the ability to bring 4D modeling to the world of AR, viewing the model and the schedule together, on site, in context. Now, let us fast forward to March 2020, and a new challenge faces every one of us. The world is thrown into a global pandemic. Construction sites must close. Time is lost. Schedules are completely thrown out. And of course, this brings big delay and risk to budgets. Now, I often think that through times of adversity, new opportunities will always present themselves. User needs will emerge, and suddenly, the responsibility of the product you had yesterday might need to play a completely different role tomorrow. And so, for our team, this last year has been a time for reacting and adapting to change, finding new ways that our technology can keep the construction industry moving forwards. And so now, with our remote viewing capabilities, one worker can be out on site viewing the build progress in AR, whilst 40 site managers and surveyors are back in the office, socially distanced around computer screens, viewing the 3D model holograms directly through the eyes of our construction worker on site. Overall, this minimizes the number of workers needed on site without compromising the review and sign-off at key stages of the build. So the technology is finally here to answer the needs of the construction industry. A completely new way of working that is safer and far more efficient. Yet, as a product leader, I know that design also has a huge role to play to ensure that we achieve genuine adoption and overcome the barriers to entry. So let us think about the product styling and aesthetics. I'll never forget a conversation I had a few years back with my uncle, who's a trained architect. He said, "You must consider the construction site like a school playground. The opportunity for mockery is everywhere. Standing out, being seen to be different, could play a damaging role for product adoption." This really got me thinking about how we must approach our product styling, staying away from the futuristic styling cues of Tron or Iron Man with their fictional AR headsets. We must keep it believable, staying true to what is familiar on a construction site. This product must blend in to be truly adopted, not stick out and offer opportunity for rejection. I believe that the user must be at the heart of every decision we make. Truly understanding their needs is critical. The technology must sit in the background and enhance the day-to-day, not hinder and get in the way. The ergonomics of a head-worn device are key. Careful consideration to the weight balance of our internal technology. The choice of materials that interact with the head, sensitive to the challenging environments of concrete dust, dirt and moisture. The changing environments from the bleak winter days in Sweden to the heat of Dubai. Our product must be able to accommodate all of our users' needs. So as designers, we have a huge responsibility to ensure that this new technology stands a chance. If the product experience provides any opportunity to turn off our users, then this technology fails before it's even got off the ground. And so the user remains at the heart of our story. And it is with this approach that we believe we can bring real change. So the full power of 3D is here to stay. And for the construction industry, it's finally time to start building it right first time. Thank you very much for listening.